Okay. Good morning, everybody. My name is Marcus. I'm the moderator for this event. You might have seen me in other events, but so I welcome you to this event today. First of all, I'd like to invite all of you who have taken your busy time on the Saturday morning to attend this event. Before we start, I'd like to remind all participants on the following. Remember to log in with your full name because the certificate of attendance will be based on the name written on the Zoom. Then I've asked the speakers, they have said that you can unmute yourself to ask any question at any time. Or if you wish to, you can use the chat feature and then I will read out the question to the speakers. Then the next thing is ensure that your microphone is muted during the presentation. Then please ensure when your camera on, your shirt is also on because we want to ensure proper attire when the camera is on as well. So, and also remember that there will be a group photo at the end of this presentation. Then this online talk is being recorded for record keeping. So before we actually introduce the speaker, the esteemed speakers, I'd like to bring upon the attention of all participants today that today is the first in the series of this Penang Engineering Consultant Showcase Project Series organized in conjunction with YES Chairman. So in the first part of this series, we invite SW Consultant and Associates to present their showcase project, which is the Kek Lok Temple Pavillion. So this series is still open for registration by any Penang consultant who wish to showcase their own projects as a form of sharing to our own members of the capabilities of our own Penang consultants. So not just that we picture consultants and projects from all from overseas or KL. Now it's time to showcase our own Penang consultants and their showcase project. Without further ado, I present to you a brief introduction of our speakers. So our speaker number one is IR Lim Ten Huat, who is a registered professional engineer with the BEM and corporate member of IEM. He's currently the managing director for SW Consultants and Associates in Berhad. He is a graduate of the University of Manchester in the UK. In 1980, a long time ago, he began his career at Min Consult for 8 years. And thereafter, he founded his own consultancy in Penang in 1988 at Lorong Amoy, Georgetown, and has since designed projects ranging from highway and bridges, power station, palm oil milling, waste and water treatment plant, and also housing and development. For our second speaker, IR Lim Sin Chun, he's also a registered professional engineer with the BEM and corporate member of IEM as well. He's currently the senior engineer for SW Consultant and Associates. And he began his career at Architect Archi Prima for 2 years before furthering his studies for a BSc degree. And thereafter, he graduated from UTM, University Technology Malaysia in 1997 before joining SW in 2000. Yeah, his career experience also ranges from housing and development, palm oil milling, to waste and water treatment plant. So without further ado, I like to welcome our speaker. Speaker number one, IR Lim Ten Huat.
Okay.
That's the slide. Marcus, the slide.
Some technical problem. Yeah, good morning, everybody. Welcome to the first series of the Penang Consultant Showcase project. and somehow we volunteered with the first one, showing our project at Kek Lok, but this project is somehow a bit dated. It had actually occurred more than 14 years ago, right? So, but anyway, I think a lot of people have not seen the actual construction at close range, how we actually managed to overcome the various challenges that we faced during the project, right? So the first slide is okay. Okay, I'm going to do the introduction and then later the temple background, the project scope, stakeholder, the design overview before we hand over to engineer Lim Sin Chun to brief you through the actual construction of the project in more detail. To kind of uh, okay, but our company is called SW Consultant and Associated. We started in 1990 in Penang. We started off trying to do a project in Penang called Taman Lompai that we started, and I thought we just came here for a few years, then I'll be going back to KL to continue our career. But somehow I got stuck here for the up to now lah, over 30 years coming in Penang. So in the meantime, when we are doing the project that lasted more than 10 years, we were involved in various type of projects, mostly in the palm oil industry, mainly in the milling, palm oil milling and palm oil refinery. Basically, we started off with the on the portion of the structural and foundation for the palm oil milling, but eventually we also got involved in the actual development of new technology in the palm oil industry, and then building in various type of condition, like in constructing in very remote area like in Indonesia and Sabah Sarawak, and apart from that, we do some industrial factories, uh, but the normal type of factories like in the industrial park. Apart from housing and development that we first started with Taman Lompai, but eventually we do have other projects in the Penang, right, as well as other places in Malaysia. Infrastructure design, infrastructure design, huh? Uh, I, I think infrastructure design, we don't do that much, infrastructure design, but water infrastructure, yes. If we, then we really got into water engineering and technology, basically in potable water as well as the wastewater, right? We have some famous and infamous project that you can see a bit later. Landmark project like iconic structure like Kek Lok, historical restoration, basically out of interest on heritage building, how to improve the structure. Sometimes client do have some weird request, like some one I did in Albania Street where they request actually a spa on top of the kitchen. So that kind of thing. Oil and gas, very little in fact. The only one that we did was a bitumen plant in Seberang Prime. Area that we cover over our last 30 years in Penang, we have projects, we have done projects in India, in China, Thailand, Cambodia, right, Sabah, Sarawak, Indonesia, basically this regional area, right. Most of the project is on the turnkey project, that Malaysian investors have a joint venture with the foreign partner. Like in Calcutta, we did the one quite a big water treatment plant with the like this one in Calcutta. The joint venture partner was a Haldia water treatment plant joint venture with a part of the what call this uh, I can't remember the Haldia is one of the bigger groups in India. They own the plant, but our working partner was under Rank Hill Utility, right? Then there are some others that we have done. The so-called infamous project is what we did was we also did the wastewater plant in for Linus Advanced Material in Gebeng here in Kuantan, right? Till today they are still allowed to run it, so they still have to find a long-term solution for the solid waste disposal. But we are looking after the liquid waste disposal, not the waste, not so much the liquid waste lah, not so much the solid waste. Sorry, the radioactive part was handled by the client themselves. We were doing mostly the schedule waste, the BOD, COD stuff lah. And other that the project that we did, we the small palm oil mill in Ranau in Sabah. This was a project that the DOE have what's called impose a condition of a zero discharge. So at the end, we had to do the disposal using compost that consume all the effluent. Then apart from that, the Taman Lumpai project that we first started off in 1986, I think, right? And it's already completed lah, with 13 blocks of high-rise and low-rise building. Okay. Okay. Let's start on the subject of today, the Kek Lok Pavilion, right? Okay. Then you have uh, just a feedback here. Okay, a little bit about the temple. It is the largest Buddhist temple in Malaysia, and originally it was built around 1890, and again improved on it again in 1930, right? Right. Of course, the main attraction, the kind of iconic structure is the seven-story pagoda, and now is the Kuan Yin Pavilion, right? Uh, it's a bit straight, a kind of a very strange way that we came across this project. It was in I think it was in 2008 that Mr. Jimmy Koo of Jimmy Koo Consulting and Associate approached us to see whether we can take over the steel structure that is on the roof. He was the consultant for the superstructure, the concrete part of it, right? Including I think the foundation and all that, right? So he is right. He is at that particular time the base of the structure was completed. The column was coming up at the time, and I think the committee have approached him with two design actually. The first design was in concrete, and it was way too heavy for the existing column and the foundation to take. So the committee went back again to China, and in this time it was the School of Architecture in Zhejiang University, and they put up another design in steel, and even that it came back too heavy. It was over 4,000 tons of steel on the roof, and I think Jimmy Koo felt that it was way too heavy for the column that is standing so high up, right? So the committee actually at first talked to us, see whether we can do some kind of value engineering to reduce the total weight of the structure, but it will be still in steel rather in concrete. And after studying it, then we say, okay, we can check through the design, and then we'll make some proposal, and that's it. But after we came back to them somewhere at the end of 2008, uh, they say, okay, since you have say it's possible, how are we going to build it? And say, hey, I thought we are being hired just to do value engineering, check it, and then come back to you and say that it can be built, and then here's the design. But he said, oh yeah, but how are we going to build it? It's going to be that high and all that. No, so our original estimated time in which we are expected to spend on this job was estimated at 3 weeks, but eventually we spent about 11 months doing doing this job, right? So, okay, as you can see from the slide, we went from the initial scope where we are supposed to do value engineering for the main roof, right? And then we went to extend the scope to both covering the design of temporary work, right? And also basically supervising the construction. Yeah? And then the final part where we have to do the roof redesign and then the construction of the temporary platform and modification and the additional scope. Okay, let's go into let's have a look at the overall design of the thing, the design overview. Okay, as you can see, the structure is quite high. The Kuan Yin statue itself is actually is more than plus the foot thing is more than 100 feet high, and then the various stages of the roof. The roof is itself is we had 16 columns, but they are all in a cascading form where not all the columns are supporting the roof. So there will be a stage at where we have to do some transfer from the upper part of the roof to transmit it the load right down to the column and then the base of the structure. Right? Overall, I think at the this is the this so drawing actually is the actual one that we started off. But as you can see later, that as we progresses, the design itself has changed, keep on changing. And I remember a story where I asked the chief abbot of Kek Lok. I say, by the way, we come in halfway. Can I be introduced to the architect? He said, oh, architect? There is no architect. I said, then who is the architect? He said, I'm the architect. The chief able say he's the architect. Then I say, where did you get this idea of building this? And then you got that architectural detail that you have worked out. Then he took out this big a page out of the calendar, and then you're showing a similar type of temple in China, and they say, well, I'm trying to follow this one. so so I can say that you can say that the chief abbot is the architect of this pavilion. Right? So some statistic, the actual Kuan Yin statue is over 400 tons, and then the decorative and other stuff is 300 tons, and the concrete that have been used there is G35. Okay, the platform in which the statue is sitting on, that part was done by, I think, Dimiku and Associate. It was a post-tension beam platform in which the statue is seated upon, right? And then the column itself is very high, so I believe they have this tie beam to actually shorten the column height, like a form of bracing a tie. Then the third level of the concrete tie beam, that is where Dimiku and Associate job stops, and our part starts after this concrete beam. You can see this is the plan of the base in which the statue is sitting on. They consist of 4 post-tension beams seated. I believe the foundation is caisson. They use a hand dug caisson at that time. Yeah, this is the 4 post-tension beam. I think the post-tension was done by VSL. This is the walkway around the base of the pavilion. Let's look at the challenges that we face. Bearing in mind that the RC structure was too heavy, so that's why we came in to change it into steel. But even changing it to steel, we still have to comply with the architecture that was previously being determined, like the depth of the beam, the width of the beam. From the structural point of view, actually the beam themselves need not be that deep, right, and big, but just because we wanted the impact from the architectural point of view, that we end up having such a big beam. The beams are all actually prefabricated box girder in steel, right? And we have to imagine that some of the beams themselves are some 26 meters and weigh much, maybe 20-30 tons. But the lifting capacity of my crane that we were having on the site is only 5 tons. So the biggest challenge was, how am I going to put up a 30-ton beam on at that height, and all I have is a 5-ton crane. I think that was one of the biggest challenges, lah, right? And also working at quite high is unlike doing a high-rise building where you probably have a lot of cover, and then you don't feel that you know you're trying to work in the air alone. But you really look at the cross section of the pavilion, you can see that we can't do much over the statue, the Kuan Yin statue, because the Kuan Yin statue was erected before the pavilion was up. So we are not allowed to sit on top of the statue, lah, of course. Although we did have some scaffolding trying to support the first concreting of the last concrete RC beam. So working at a very tall height was a problem, right? And supporting formwork, but the formwork that we were supporting basically is only for the RC beam. The rest is all prefabricated girders, steel girder that have to be installed at that height. But as we go along, we will explain how we managed to overcome the problem. The steel superstructure solution that we propose. Okay. The first layer, the G, what call this? Let me get my bearing. After the concrete beam was constructed, we have to even before the temporary platform is got. Let me see. Okay, after the concrete beam has been concreted, there was another element in which we have to put a steel girdle on top of it, lah. Right? Let me see whether let's go back a bit. No, have. Right. So we to overcome the problem of how are we going to reach higher, because the scaffolding only stop at the level of the RC beam. So to go to higher levels, higher than the 44-meter level, the next level in which we have to reach was a 54-meter level, right? And there's so much jointing, and because since the beam is 20 or 30 tons, the very obvious way to install this thing was to transport or to lift part by part of the beam to somewhere in the air to be jointed and installed. So how are we going to do that? So I think originally the first contractor, we had actually two contractors here. The first contractor, they did propose, but nothing came out of it. So when we came in, we say, okay, we agreed that there should be a platform somewhere above the level number one, so that we can do the jointing and then the erection where the actually the welders and the workers could operate uh, at that level for the 54-meter level, right? So at the end, so there is who is going to do that platform? So at the end, this is a temporary platform, and we ended up having to design the platform. I think later, I think under Lim Sin Chun, you will be able to see the detail that we did for the temporary platform. Okay, this is a temporary platform that will allow us to reach upward to do the work above that level. And okay, the transfer beam, after you see, you can see the last column, the inner column only go that far, and there is another level at the 54 to 64 level that need to be seated upon, but there is no column underneath. So there is a transfer here. So there's the introduction of another prefab box girdle that will do the transfer from the higher level to the foundation. And then there's another part in which actually the permanent platform level, the permanent platform is actually what we call the roof, the roof. Though the idea was how are we going to sit all that the stupa, the crown of the pavilion, which itself was quite heavy. It weighs probably tens of tons as well. At the same time, we have to think about how are we going to support the decorative dome that is occurring below the roof. That's how we decided that there should be a permanent platform level consisting of steel trusses and all that. And as we go along, as you can see how we're going to support this thing, right? Okay. You see, to support the decorative dome or the chao in the Chinese, they call it the chao. And this thing weighs around 60 to 70 tons. It's all pretty heavy stuff. And even this decorative dome itself is made out of 4 mm plates that is cut to shape and then welded together. Again, you can see the photograph of the construction a little bit later, right? And the way we have what's called we thought about how are we going to support this one because it's going all around into a three-dimensional area. So we say the very obvious way is to actually put the tie that is tied to the bottom of the truss onto the top of the decorative dome in a series of tie with plenty of redundancy in case because you need to adjust it and in case we can try to uh, uh, have some factor of safety, basically having a lot more redundancy in case the bolt is overstressed and break or the tie that is slack or something like that. So we did have a lot more ties than what our numbers tell us. Okay. Originally, the one of the requests from the client was that during maintenance, eventually after the whole thing is completed, how are we going to do maintenance on the underside of the decorative dome? Basically, in terms of repainting and doing maintenance, because you need to because the whole thing is in steel. So you need to do some touch-up work and maintenance throughout the lifespan of the structure. So we came up with a sliding platform, but unfortunately, this was never built lah because I think at the end, the chief abbot says that it doesn't tie in with his architecture, and we were not allowed to install this sliding platform. Although the I beams, the traveling girder was installed, but only the platform was not installed due to his objection. so so we didn't get to build it lah. He said it looks too much like a factory. So yeah, until today it's not built this thing. So transfer beam, we have talked about the transfer beam on this one. Permanent platform. Okay. That's a plan view of the pavilion. We have the outer ring and then the inner ring. The inner ring is where it supported on the transfer beam. Okay. This is the view of the temporary platform that we propose to cater for the working platform for all the work that is above the 54-meter level. And you imagine that we have to design in such a way that the platform is very light, right? And at the same time, able to take those heavy fabrication that we intend to put on top of this thing before they are finally installed in their final position. Uh, the trusses are in the hollow section truss, but the covering we only allowed to use a very a thick plywood lah, not steel because it will be too heavy. So at the end, we did have only a plywood cover, but that's why the trusses are pretty close together so that even we try we won't miss and then get what you call drop through the the panel lah, will drop through the plywood floor. And this one is the level 2. This one. Okay. Inner ring. This. The permanent platform is the one that the stupa will sit on. There are two purpose. The design we actually have two use for it. One is to take the vertical load from the stupa itself, and then the second function is to hang decorative uh, the decorative pattern that is occurring below the permanent platform. The decorative dome, and then the small circle and the big circle is the final stupa that is representative of the temple that you see today, the symbol of Buddhism. Okay, that's it. But now we will now go through the 3D, but I'll pass that representation to Engineer Lim Sing Chun to present it to you.
Good morning, everyone. My name is Lim Sing Chun. From the previous slide, Mr. Lim has presented the concept design of the structural. So I will continue with my part on the construction of the steel structural in 3D view. This is the 3D model showing the view of the whole steel structure, completed view of the whole steel structure. Generally, there are 3 layers of roof. In this structure, there are some special features shown here. First, there is a decorative corners and the dragon beard at every layer of floor. Second, the decorative or choujing is installed in between the level 2 and level 3. And last, there is a 9 number of stupas on top of level 3. Okay, I will going through the sequence of how the steel structural element is installed step by step. This is the completed RC beam level. The steel structural will start from here. The first element to be installed is the box girder beam. All the steel beam will install on top of the RC beam as shown in the picture. This is another picture showing the builder is installing the steel beam segmentally on top of the RC perimeter. Okay, now you all may have a question. Why we need to stack a steel beam on top of the RC beam in the same span? In fact, the RC beam itself is already 1.2 meter deep, and the steel beam itself is 2.4 meter deep. All right, the answer is to facilitate the installation work of the decorative corners and the dragon beard. Because all the decorative features, as mentioned, are made from steel. And we just directly welded those decorative features to the steel beam. Okay, the green elements shown are the dragon beard. Those to be installed at every corner of the beam. And the light green elements shown are the decorative corners. This picture showing the decorative corners that welded to the steel beam. This is another picture showing the dragon beard and the decorative corners that has been completed in one span. This is a closer view. From here, we can see that the surface of the steel beam is fully covered by the decorative features. Once the decorative features has been installed, subsequently the artists from the China will start painting the decorative corners, because the painting work will take few months to complete. In the next section, part 2, we will show the completed art painting work. The next element to install is the prefabricated steel column. This is a cross-section view of the prefabricated columns. The reason why we custom-made the column mainly is ease of connecting the beam to the column at 135-degree angle in plan view. This picture is showing the sequence of the builder installing the column to the base plate. When 8 numbers of column has been installed, the following element to fit in is the rafter in between the column and the external perimeter beam as shown. The subsequent element to install is the column tie beam in red color. This is another picture showing the builder installing the column tie beam. The purlin shown in the magenta color is the next element to install onto the rafter. This is another closer view of the purlin that has been installed to the rafter. The connection detail, you can see the connection detail, rafter, the purlin onto the rafter. After that, the next major element is to fit in install the temporary truss onto the tie beam. This picture is showing the builder installing the secondary truss to the main truss. This is another view of the secondary truss has been installed. This model shows when all the temporary trusses were installed, they will cover about 40 meter by 40 meter. This is bottom view of the temporary trusses. Okay, during the installation of the trusses, at the same time, the builder also have to erect the circular column casing segmentally, because the original column design is circular column in 2.1 diameter with 20 mm thick. Since we have modified it to prefab column, hence we need to cover it back with 4 mm thick circular casing to remain the original outlook. This picture is showing the circular casing has been completed. This is an internal view showing how the casing support to the prefab column. When all the temporary trusses has been fully installed, the subsequent step is to install the hollow section floor joist on top, then following by the timber plank laying. This is to form the temporary working platform for the builders. This temporary platform is a significant structural element for this project. Without this platform, we are unable to proceed with the installation work for the following level. This is mainly due to the limitation of the tower crane. Only 5 tons of maximum lifting. For the element exceeding 5 tons, it has to be broken down into the few pieces and lift up to this platform to be assembled back. Once done, then we are able to continue with the installation work. Furthermore, based on the site situation, the scaffolding was unable to erect in the middle of the Kuan Yin statues. Hence, the temporary truss system is the best option for this project. The next element installed is the second layer of box girder on top of the prefab column. There are 8 number of perimeter box girder to be installed in second layer. Okay, this video shows the second layer of box girder has been completed. Now they are starting to install the transfer beam. The transfer beam shown in the pink color in this model, which is the next element to be installed. This video is showing the builder is installing the transfer beam jointed in 4 segments. From this video, we also can see that all the workers are working on the temporary working platform as mentioned just now. During the installation of the transfer beam, at the same time, they are start to install the decorative corners and the dragon beard on the second layer box girder beam. The next element to install is the second layer of prefab column on the transfer beam. After this, the following step is to install the rafter, which is the same procedure as level 1. Rafter. The next element to install is the tie beam and the purlins. The procedure is also same as the level 1. For all the second layer of prefab columns, also required to cover by the circular casing as well. From this picture, we can see that the right side casing has been completed and the left side column have left up the bottom segment to be installed. Okay, the next interesting element to be installed is to assemble the decorative dome or Chao Jing. The decorative dome is the prime decorative features for this project. This picture is showing the builder assembling 2 segments of dome on the temporary working platform. Generally, the dome is consists 2 tiers of decorative features. The lower tiers have 16 segments and the upper tiers have 12 segments. This picture is showing the builder is assembling the 3rd segment of the lower tiers. This is a closer view of showing the two tiers of the decorative dome or Chaojing has been installed. Once the decorative dome has been assembled, the top view will look like this. This is a photo show the worker is covering the gap with the aluminum sheet. The next element installed is the third layer of box girder onto the second layer of prefab columns. Once complete, the following step is to install the permanent truss to the steel beam. This picture is showing the permanent truss that has been fully installed. The permanent truss are another essential structural elements. The truss are not only designed to support the 9 numbers of stupas on the top, but they also act as a support system to hang the decorative dome below it. The next step is to raise the decorative dome to the designated level and to be hung onto this permanent truss with tie. This is a different view of the decorative dome to be hung to the permanent truss. These trusses have at least 3 or 6 number of ties to hang the decorative dome. This is the bottom view of the decorative dome. The picture shown here is the actual look of the decorative dome in the night scene. The next element to fit in are the decorative corners and the dragon beard welded to the third layer of steel beam. At the same time, they also concreting the top floor. The last element to be installed here is the 9 numbers of stupas. This picture shows the builder is erecting the base of the main mini stupas. This photo is shown the 3 number of mini stupas that has been completed, and they are also start erecting the base of the main stupas. The main stupas is double the size of the mini stupas. It is 7.2 diameter and 50-meter height. This photo is showing all the stupas. One has been completed. After this, the next step is to cover the 3 layers of roof. All roofs are designed as double roof, which is lightweight concrete slab beneath it with roof tiles stacked on top. This photo is showing that the builder is preparing the slab soffit with the nominal reinforcement. Then they start concreting the roof slab. After that, they are starting to lay the roof tiles on top. This is the picture showing the completed of the roof work. The final step is to dismantle the temporary working platform. All the temporary truss to be dismantled and removed away. Once the temporary truss are fully removed, the whole steel structure has been completed. And the Guan Yin Statue Officer Open Ceremony was held on December 2009. This project was considered completed on time. However, after the event of the ceremony, there are some extension work that carry out because the client has felt that the present stupa's height were not visible and also not in a good proportion. Hence, all the stupas need to be raised up by 3.5 meter. From this drawing, you can see the left side is the original being built and the right side is the modification. This is the raised up platform, 3.5 meter high. Those are the drawings showing the origin. This is the modification of the stupa's layout. It's the tie back truss at the corner. This is the section of the parameter staging and also the tie back truss. This is a modified base frame for all the stupas. Okay, look at this 3D view showing the sequence how the modification to be done. Each of the stupas need to be raised up by modifying the base frame one by one. Once done, the parameter staging will be installed to cover all the modified base frame. This picture is showing all the stupas has been raised up in phase 2. Okay, this is the end of my slide. Okay, before I end my presentation, I will run the slide again very quickly to show how the structural element to build up in 3D modeling. Okay, look at the 3D model, at the sequence, how the structural element build up from this temporary truss, platform, box girder, transfer beam, second layer of prefab column, casing, decorative dome, third layer of truss, then third layer of beam and truss, tie, stupas. Okay. Okay. Okay, that's all. Or you want to take it? Okay, there's a question here. Right.
Thank you to the first part of the presentation. I've seen that there is a couple of questions in the chat group. So before we adjourn for a 5-minute toilet break, I think we allow both of our speaker to address the question inside the chat. So if you will, speakers. So the first question by Zhao Hu Wan, I think, I put it this way, I will read out the question and the speaker will answer directly lah. So the first question by engineer Zhao, the tie beams, I think there's a typo. The tie beams were constructed by a steel plate pressed into the rectangular shape with internal reinforcement, question mark. So I believe I try to interpret for the speakers. I think engineer Zhao is asking about the RC tie beam before the steel roof. So he's asking whether they are steel plate pressed into rectangular shape. internal rebar. What does the speaker
Oh,
out
okay,
of it?
okay. You mean what provision we made to attach our steel box girder onto the RC beam? I hope this is what you're asking.
Engineer Zhao, would you like to clarify your question?
Yeah, I see all your box girder and your tie beam are fabricated from the steel plate, isn't it? So you are actually prefab all these things in the factory using the steel plate, am I right?
No, you mean you see that the prefabricated girder are fabricated below
Yeah.
the schedule, and then we are lifting it piece by piece up. To the way that we attach the RC beam to the box girder is via the
Yeah, this
hold
one,
down.
this one I'm talking about. Yes.
Oh, you are talking about the column. Okay.
Column, yeah.
It's not the beam, this is a column.
Yeah.
Okay, this column, why do we, you can see some of the hold down board that is coming out of the concrete beam, right? That is installed during the concreting of the RC beam. The reason why this plate is called installed first and not attached to the column is because it actually exceeded our 5 tons. Our crane only can lift 5 tons, And this plate we are using about 25 mm base plate. They are quite heavy. They ngam over the over the 5 tons. So we decided that it should be installed separately. So we lift the base plate up. We bolt it down to the hold down bolt, and then only later that we will lift the prefabricated column and installed and welded on site onto the base plate. Is that answering your question?
Okay.
So this is all
yeah.
all prefab in the factory and assembled at the site piece by piece because I using the steel columns, using the steel plate instead of using a concrete is to reduce the weight, isn't it?
Yeah. The to use the steel is to reduce the original design, which was much heavier. The concrete there's two options originally proposed in concrete, and the first version of steel was done in Zhejiang University, and that weigh like something like, if I'm not mistaken, it's about 4,000 over tons. The overall weight of the roof lah. So I believe there's a similar question: how much weight do we manage to save? The concrete one weighing 6 to 8. I think it's close to 8,000 tons. That's why they rule that out. They moved to the first steel option about 4,000 over tons. And eventually, after we finish, we are doing around 1,200 over tons. So we managed to reduce from original about 8,000 tons concrete roof and 4,000 ton steel roof to 1,200 tons. That's what we managed to achieve lah, right?
Okay, I think we are a bit pressed for time. We continue to the next question by Engineer Ng Sing Ji. Very challenging and interesting project indeed. From foundation to roof, it involves several engineers and contractors working hand in hand to get this iconic structure completed and standing proud. Just wonder who was the engineers and contractor that signed off the G form?
Haha, this is a good question, because there's the first question I asked the chief aboard, who is the architect. There is none. There's no architect, right? And I think I don't know if maybe they have the architect lah, but I'm not aware of it. Even at our stage for the pavilion, so I'm not sure who signed off the G form or whether there are any G form signed, right? So I think this is a public interesting. I think the council also has been rather quiet on this thing, right? So I'm not sure. Only the client will know.
Okay. The next question by Engineer Lai Chuan Hian. Not sure if you have explained about it. Would like to ask why box girder is used instead of I-steel section?
Okay, if you are using standard section, there is no section of this size lah. Even if we are using I section, it have to be prefabricated I section. But I think why we use box girdle is number one is actually when we went there, people decided to use box girdle lah. But I can see that one of the main reason why you're using box girdle is to actually to comply with the architectural design. As we can see that when we welded all the decorative what call these cornices and the dragon beard and all that it need that kind of height and all that to attach all this pattern, you know. So to me, why from the structural point of view, you can use any section, but from the architectural point of view, the box girder seems to be able to fit all that lah. And also one of the main reason that I can think of is that because most of the decorative features are welded on one side, you can imagine that there is a lot of torsion involved, and then the box girder is very good in that, in terms of torsional rigidity. So after we fixed it, there is hardly any deformation because of the big size and big torsional capacity of the box girder. So I hope I answer your question.
Okay, and the last one by Engineer Zhao also, I think the speaker might have addressed this just now, the ratio reduction between initial concrete beam design versus the later steel beam structure. So yeah, the speaker has addressed that. Okay, so we are also running short of time. We will now take a 5-minute break, toilet break. So we shall return at 10:43. Okay, 10:43. So we will continue part 2 on from there. Thank you, everyone. Okay, everyone back online. Okay, so without further ado, we shall proceed with part 2 of the presentation. This time back to speaker number 1, IR Lim Tian Huat. Speaker Lim, would you, the floor is yours, sorry.
This is the part that the masonry casing that they use for the 16 columns. I think they are all they came from Guangdong, I think, in China. How they erect the casing first with the reinforced concrete center. Yeah, you see each ring is stacked on top of each other. You see, they're all shipped in from China. This is the part. This is the casing for the rectangular beam, tie beam that you see on the at the pavilion now. Quite artistic work. They can carve a trench out of a solid piece of rock. That's where they put the rebar inside the casing. You can see more of the same. The view from afar. They have probably reached the level number 1, where they're going to install the RC beam. This is the formwork for the RC beam. It's quite heavy because it's quite long. It's 20 meter almost. You see the heavy scaffolding that they use. That's the name of the donor, I believe. Yeah, $2 million per tiang, somebody is saying. This is the hold down boat that the previous engineer, Mr. Chow, have asked. You can see the installation of the hold down boats, right, uh, with the base plate for the column. Two levels of beam being cast at the same time. This is the steel aging that we install for to receive the prefabricated steel girder that is going to come on top of this. That because steel is going to be very very level or very much more accurate than concrete. So we need to have a leveling seat, That's why this angle is actually for the seating, of the upcoming girder. You see, this is after they have concreted it. This is a video. This is some of the shot that we have taken, and about this is a dragon beard, I believe, right? Is we fabricated it very close to the pavilion, within the reach of the tower crane, so that it can be lifted up. Once it's finished, then we can lift it up onto the to be installed. Okay. Some of you can see the half joint was what was done by there was a previous consultant for this steel. I believe that this is not the correct way of joining. When we took over the project, we were encountering all these half joint that we don't know what to do with it. So at the end, we had it all cut off lah. We cut it off, and we were using a straight joint on site, not half joint with the bolts that he had intended it lah, because it's not going to work. You can see this is already done before we get onto the site. You can see the gap. Once you put it two together, you cannot do this with steel because it just won't fit together one. So we at the end we replace this half joint with a straight vertical joint. Yeah, this is the mock-up model. In fact, was a very strange way. I asked Dato Go of Yuan Metal, who was leading the project for the temple, and he says, why you do the mock-up model? And then he says, how I say why you do that? He said I can do the load test. So he said he's gonna put all that and then put a lot of load on it, and then if it don't fall off, then it pass. So I think that is the layman way of doing the test lah. I suppose it serves its purpose. This is the beam that is going to sit on the RC beam, but this is the mock-up unit lah. You can see more of the same thing again, the fabrication of the decorative element. What you see here is at the time we just went to the site for the first time. This is the base plate for the column that we have previously talked about, right? Wait, we move. This is some of the element the fabrication yard. This is the fabrication yard in Ion Metal. Continue. I take a video. Checking the thickness of the paint.
This one is the nice
And then one more time. I come here. Just the beginning. I want to take the string cut down. One more time. One more time.
Okay, there was some of the quality control on the paintwork that we have checked lah. So this is the installation of the half joint thing, but at the end we cut it off and we welded it back lah. Yeah, this is the installation of the first layer dragon beard. This is the shot before the column is installed. But one thing interesting that I want to bring up is that during the installation of this steel beam, we realized that the gap between the concrete and the steel, although we put, remember we put the angle seating for the steel beam. This is due to the fact that during concreting, the scaffolding actually will go down because the concrete beam is very heavy, and then the steel beam being lighter, you'll be much more level than the concrete beam. So one of the interesting thing is how are we going to close up the gap? And somebody actually from UN Metal suggested that we should use the bolt that is holding the girdle to the concrete beam and jack it. I say that you will kill somebody inside there because the forces that generate, you are trying to lift up the concrete beam with the steel beam, which is impossible. So at the end, we recommended that we can only use non-shrink grout to close up the gap. But at that height, 40 over meters above the ground, nobody will be able to see the gap. So that's what we did. This one is the fabrication of the compound column. Now I call it a compound column because we didn't use any standard section. We actually designed and fabricated this girdle. They are supposed to be at 135 degrees eventually to cater to for the octagonal column, the shape of the pavilion. And you can see this is already put together and welded, the compound column that is going to go up, right? What you see on the right hand side here is actually the top of the column, not the bottom. There you are, delivered to the site, ready to be lifted up, minus the base plate. One thing that I need to mention is the second fabricator that we engaged actually is much more experienced than the first one, because this guy claimed to have worked on the Langkawi Sky Bridge before, so he used to work at very great heights, and with very little surrounding. So he's a very good fabricator. On the way up, and then positioning onto the base plate that is already being installed. There you are. They are trying to position it. We need to position it at the correct angle and then at the right orientation, because if not, the adjoining beam will not join properly. So they need to be careful. One of the advantage of welding the base plate later is that we can actually adjust, do some fine tuning. And see the size of the compound column itself. The original column designed by Zhejiang University was I think each column is already 30 tons, and they are made out of like 50 thick structural plate rolled into a annulus. So we got rid of it. One of the way to reduce the section size. This is much lighter, only just just under 5 tons. This column compared to 20 over tons original column. Yeah, we're welding it back onto the base plate. There you are. This is the area that we cut off the half joint, because half joint just don't work. As you can see, when they put it together, there's still a gap there, and the beam will not be level or flat. Right? So we cut it off and then we join it back using a vertical joint rather than a half joint. All by welding and not by half joint. I think one of the reasons the first consultant have used half joint is to reduce weight lah. But I think we used another method lah. So we cut it off, we welded it up on the side lah, so that we also in the way that we don't exceed the 5 tons, but we jointed it at the top lah, so that since we got a RC beam there, we can actually put on top and join it, rather than trying to do a mechanical joint. So that doesn't work. We were trying to join it. But you can see some manhole left on top of the first concrete beam, first steel beam. This is to allow us to thread it through the hold down bolt at the on top of the RC beam, and later also to ground it back, to close up the gap between the steel beam and the concrete beam. This is the installation of the tie beam. Again, more fabrication work. This is the temporary truss. Lifting up of the temporary truss. Yeah, it's much higher because I think the span is about 40 meters. Right, it's quite a big span. Temporary truss. Good. You can see everything is quite big. If you look from the bottom, it doesn't look so big. This is the casing that we managed to reduce from a 50 mm thick plate to 4 mm thick plate. So there is a big reduction. One of the method that we do to value engineer the whole thing and see where we can reduce the weight, so that they achieve the capacity of the supporting column that is already there. One of the other method that we use, if you remember the roof, we're going to put with the tiles on top. We felt that we felt that there's no need to actually do a structural grade concrete here. So we invent our own mix lah. Basically, to have concrete with a very with polystyrene beads as the aggregate, because all the purpose of this concrete was to hold the tiles that is providing the waterproofing. And at the bottom, we already got the metal deck come with the reinforcement. So this is one of the way that we managed to reduce the weight lah. Yeah, what shown in the picture here is all the different portion of the mix. Eventually, we chosen one that have a cube strength of only around 15, I believe, 15. But the it's very light. It's very light. I still have the block here in my office. So, but I think the density went from the 2.4, I think we achieve around 1.2 only. So that is another way of reducing weight lah, in terms of value engineering. Here you are the steel part, and then we are going to put in the the concrete part there. The concrete they're using is the one that we our own design mix lah, which is with the polystyrene, right? Because this is how the Chinese in China do the roof, always concrete and then tile over. The tile over, the tile over. These are you see all the black writing on it is actually the name of donors who actually each piece 25 ringgit if I'm not mistaken. All the tourists that come with all the names there, and then we use it lah. We use it for the roof. So actually the name is permanently installed on the pavilion. Right. Berlin for the temporary platform, I think. The bond deck. The bond deck. Yeah, the bond deck. After the bond deck, then we have another layer of rebar. Then concrete over again. Then tile. The installation of the decorative thing. At the same time, on the right here, you can see we are almost going to finish. Then the temple have ordered, got another team of people to sandblast the statue, the Kuan Yin statue, to clean up the things for the opening ceremony. This is the time for the casing. You see how we join it in section by section. You can see behind Nelson, I think the stool here. That's how we joined it. We have a stool on the temporary platform, and then we join it piece by piece. They weigh no more than 5 tons, and each of them is all jointed. You can see there. You see the stool that we use to level the two half of the tie of the beam. Right, on the right you can see, and the left, these are the installation stool. This is the decorative dome, I think, and one of the from this picture is it's a bit interesting. The touching of the decorative dome weigh roughly around 60 to 70 tons, but because it's installed fabricated and jointed on the temporary platform, but we still have to go up roughly around 2 meter plus 2 meter plus before we reach our tie rod or the tie to the permanent platform. So how are you going to lift something that big, weighing 60 to 70 tons? So we employ a series of jacks, and every time we jack it up, we prop it at the bottom, and then we move the jack up again, then we jack it up So we managed to move in unison all around this decorative dome. Slowly we inch our way up by jacking from the base, and then eventually some worker will be at the top there to link the tie to the decorative dome. You can see the fabrication is actually on the floor here. Then we need to lift it up to hang it on the roof. More picture of that. Yeah, that truss is the permanent roof, and then we need to jack it all up, and then to hang it to tie it down again. More picture of the roof.
那个我的脚下，他妈的公车嘛，这条。
man is the chief fabricator, the boss for QFAT Engineering. You can see how massive it is. This is the stupa that is ordered from China, I think. It comes with its own frame. Yeah. Oh, the translation. Yeah, some of the decorative feature have been painted over. This is the complete what we see. But you can see actually the decorative dome on the inside, it's not painted yet, because of the timing of the opening ceremony, they have very quickly removed our temporary platform, so the artist cannot access the center. Until today, it's not painted. If anybody notice, it's supposed to be painted. This is the second phase where we raise the stupa to a higher level. This view all lighted up. I think it's Chinese New Year. This is the view we took from the Hitam Dam. Oh yeah, one thing interesting about this, even though there's so much work being installed at the top, there was no reported accident happened here, so there must have been. Well, yeah. In fact, Marcus just remind me. I think there is one case where the Blancalas welder actually fell from the second tier onto the first tier, but he didn't drop down on the ground, but nothing happened to him. He's still okay. He didn't have to go to hospital. And then another interesting part was oh no, what are you going to do with the toilet? Every time you want to go to toilet, you have to walk down 40-50 meters of steps. So in the beginning, when I suggested, why don't we put a portable toilet on top? It was a big objection from the chief airport. He said, "How can you do that? You can't put a toilet on top of Kuan Yin head." So that's it. And then they say, what happened if somebody is to without permission urinate from the top? He said the last guy who did it, something happened to his genitals, so they will never do it again. So I thought that was a funny story. Nah, okay, now I pass back to Nelson. He told me the same story.
Okay, this art painting work. Okay, this is the artist from the China. They start painting on the box girder. This is the RC beam part. The top is the decorative corner. This part also the RC beam. They start painting it with the facing. This is a completed view. Another few nice picture from the top. This is a colorful shown there. Decorative corners has painting work has been completed. Few nice picture.
Why Mr. Lee not on top of the because make it to the top.
It's a nice picture again. Completed view.
A microphone.
This is the color of the decorative corners. Each of the center of the painting have different symbol. Different. This is a blow up. And this is another painting work. This is a location. Just now what we've seen, the artwork is located here. And then this is from here. These are decorative corners. Okay, from here we can see this is the access way to our working platform. This this is what we use to access way. This is the project manager. This this is a QS. This is a contractor, QFAT. It's on the working platform. Okay. Before we end of the section, this very interesting video got by the contractor. What we can see here. It is a dragon, rainbow dragon crab. These also can find in the YouTube.
Show the checklist.
Okay, this is the end of the presentation.
Okay, I see our lively chat box has a lot of questions already. So I think let's wait for the speaker to pull up their chat window as well. Is it ready? Chat window.
Yeah.
So as always, I will read out the question and the speaker will collectively answer the questions posed in the chat group. Okay. So the first question by engineer Pu Kun Tai is that the granite casing used as permanent formwork for the concrete beam. Did you consider installing shear stud between the inner face casing and concrete beam to prevent it from shearing off in the long run, or do you think that is not necessary?
Yeah, as you can see, okay, number one, that part of the work is actually supervised by Jimmy Koo, right? He was supervised by engineer Jimmy Koo. But anyway, I from the look of it, I felt that it's not necessary as well, because considering the bonding between the granite block and the in situ concrete will be more than sufficient to actually hold the weight of the casing. So the question, the answer actually is, I feel it's not necessary as well, because of the very rough surface of the casing. But one thing interesting when we talk about the casing, if we go to the site today and you look very closely at the granite casing, the round one, I think you will notice that there's some micro cracks on the surface. So although that job is not under us, one of the reasons I think is a possible reason is when they concreted the column, they actually did it. If we look at some of the images, you can see that the height in which they concreted is quite high. They didn't do it in the short section. They did it in quite a long section. And when you do vibrate the concrete, you build up the pressure, inside the casing. So that pressure cannot go away until the concrete is set. So I think that in some ways you actually pre-stress the casing. That's why now you can see that tension inside the casing have caused the casing to crack. So actually in future, if anybody is using this method, they should consider the pressure that is exerted on each portion of the casing, so that you don't try to do concreting with very what's called big pores, rather smaller pores, so that the concrete actually harden and not cause too much stress in the casing, right? Then the next question is, Marcus, the next question.
Okay, the next question now also from engineer Ku, who says that a lot of welding for huge steel members at the site. What were the type of assuring tests you have carried out for the welds?
Wow, that's an interesting one. We didn't carry out too many tests, but most of the tests we did was visual, and by die test if we suspect it to crack. But just imagine that most of the welding are just for structural members, not very high stress because of the large size of the section. The stress is actually very small. In fact, the section, by virtue of its size requirement, actually is we can consider it as a very over design in terms of structural requirements. But the architect, in this particular case, the architecture requirement was much more than the structural requirement. Like somebody asked whether we can use a I-beam or I-section. Probably yes, but but we never satisfy the architecture requirement. So the kind of test that we do is quite minimum, mostly visual and die test if you suspect it to crack. But so far, no such thing. Most of the welding we did was the fillet weld, butt weld sort of things. Joining two sections together in the plate. But precaution taken is most of the joints are beveled before we weld, so that the plate that we use is around 20 mm thick. So we bevel the edges using different size welding rod to build up the weld over the 20 mm. And the next question.
Okay, the next one is a comment by engineer Zhao, who commented on, you all look very young and vibrant during the construction period.
That was 15 years ago.
Okay, then he also commented that the safety is very lacking at site and no accident at all. Really blessed by the Almighty. Then the following question is by IR Chun Teck Chiao. He mentioned that he sees the site photo presented and he's noticed that there's a connection of each beam section by tongue and groove slots before welding, question mark, or just direct butt welding joint, question mark, and he commented no PPE. Maybe there is a certain part of the slideshow that you can see that, speakers.
We actually don't have any tongue and groove, I don't know which portion you're referring to. Most of the joints are butt welded or fillet welded, but the mechanical connection, sometimes we use is a fin plate connection for the tie beam, and then the tie beam and and the purlin. The rafter connecting to the main beam. Tongue and groove, I can't see.
That one is main gutter.
That's why I say we never use tongue and groove, right?
It's a rain cutter.
Oh, this is a rain gutter. This is a rain gutter. This requirement was requested by the first designer. So he have already fabricated the girder, so we use it back only lah.
Yes.
Because we didn't want to throw anything away lah. So we modify and then we actually install it with the gutter. This is the rain gutter to bring down the water. If not, if we throw the water from the top, it may be quite avalanche. You can see. So we actually channel the water down to the base.
This gutter only at level 1.
Only at level 1.
Level 2 and level 3 don't have any gutter.
Okay, the next question by Engineer Ng Sing Chi. Are scheduled or routine maintenance inspection necessary?
Oh, that's a very good question. In fact, we brought it up to the owner that there should be an inspection. But unfortunately, you can see now, even today, there is a permanent set of scaffolding type of access being provided by the temple. Because I think there was a very basic question I asked at the very beginning, who is the architect? Why is maintenance access not provided during the construction? Well, there was the oversight by the owner because the owner is the architect. So at the end, we have to live without the access. But I did recommend that the inspection should be carried out from time to time by qualified people, right? Although the structure is greatly over-designed in terms of structural strength and the thickness, and even we specifying a very high painting standard of using polyurea and a type of epoxy with the finishing coat. But I really do recommend that the owner have a regular inspection, maybe every 3 to 5 years, have a report made out by the qualified inspector.
Okay. Then the last question by Engineer Zhao again. He is talking about no binder or ring around the casing column steel rebar ?
What
Binder or ring around
the casing column? Yeah, there is actually. If you think, if you are saying that binder is you mean the shear reinforcement, the ring. There is actually a ring inside, around the rebar, for the column. Yeah, you can actually see the rebar. Let me show you. Go back to the column. When you can see the ring there. You can see the ring they are lifting down on the top photo. You can see there's a ring binding the vertical rebar. The shear links are basically structural engineer. We call it the shear link. The shear links is actually in place, and then the masonry work is actually only act like a formwork for the column. So there is a binder or ring around the thing, but not around the casing itself That's why you earlier I mentioned about the crack caused by the vibrated concrete, putting a stress on the ring. That's what happened But there's no ring you will look terrible if we have a ring around the casing, right? I hope I answered that question.
Okay, are there any more questions addressed to the two speakers? You can unmute yourself and ask directly instead of chatting. If there are none, then I would like to conclude this exciting seminar and invite our executive committee, Ms. stay to present a certificate of appreciation to the speakers. Let me pull up the.
Okay. IEM Penang branch would like to present the certificate of appreciation to the speakers for this talk. Thank you, Engineer Lim Tian Wat, for sharing your experience in this challenging and impressive iconic project which stands proud in Penang. Okay, next slide. Also, thanks to Engineer Nelson Lim Sin Chun for the talk and showing us all the photos and videos. Thank you very much.
Okay.
Can we log out now?
I think we need
yeah.
a group photo first.
Group
Good.
photo.
But as the one more thing I'd like to say to everyone, especially all Penang local consultant, this series we hope to continue this series in collaboration with the Young Engineer Section IEM. If you have anything you wish to share to our local members here under this series showcase project by by Penang Engineering Consultant, then you can either liaise with the secretariat or the Young Engineer Section. If you have anything, then you can have a part 2 by other company or part 3 by another company. M&E, CNS are all welcome. So we try to keep this going and do a good sharing for all our members here. Keep the spirit strong, show that Penang engineers are no less than any other engineers around the world. We have our strengths to show everyone as well. Okay, with that, I pass the floor to Julie for group photo.
Yeah. Can every one of you on your camera?